All right. Thank you all for coming and thanks for your patience in getting started. So today we have another hour and 40 minutes remaining to talk about topics in debugging. Ella, Mo, whoever, if there are questions in the chat, please flag them to me as we're going or whenever you feel like it's appropriate to get started. Thank you all so much for joining. Have some fun in the chat while we get started. Why don't you say where you're calling in from, what time of day it is. Right now, it is a Monday morning, not too early for me, but it's 10 a.m. and just coming back after a weekend. So, if I look a little rusty, I'm just getting back into things. So bear with me as we go through these exercises. So today we're going to talk about first, before you get into debugging proper, there are some troubleshooting tips that you need to make sure that you're aware of. But then we're going to get into proper debugging tools, debugging your code, debugging things that you can use in RStudio, and debugging someone else's code. There's going to be more content in here than we have time to fully cover in our 2-hour time slot, but we're going to do our best to make sure we hit the highlights. This 2-hour workshop was originally conceived as part of a 2-day workshop at RStudio conference, now known as POSIT. And the 2-day workshop was what they forgot to teach you about R. So if you see the WTF acronym in any of these materials, it stands for what they forgot. And debugging is one of those concepts. These slides were created a year or so ago, but basically I'm using a recent version of RStudio. And if you are working locally, you want to make sure you're ready to build packages. If you're working on POSIT Cloud, you don't have to worry about that. If after this workshop, you still want to learn more about debugging, there are some fabulous resources out there as well. So there's references for different blog posts, different chapters and books, and different webinars and videos as well. Everyone is you're here probably because you're familiar with these different emotions that you feel when you're debugging. So this is artwork from Allison Horse, where you might start and see something weird with your R code. And it puzzles you, so maybe you restart R and nothing's working, and then you have a meltdown, and maybe take a rest, and then you have a new idea and you finally get it. But that process can maybe be a 10-minute process, it can maybe a 2-hour process, or it might be like an overnight process. It really just depends on the scope of the debugging problem. But I will say, regardless of the scope of that problem, number 10 is always true, right? After you finish debugging, you have learned something new about your code that is valuable that you can carry forward with you. So before you get into these proper debugging tools, it is important that you know about your first steps in troubleshooting techniques. The first step is always to Google. So you can Google an exact error message. You can look on what is formerly known as RStudio Community and currently known as POSIT Community Board, has a lot of great messages there. And of course, also Stack Overflow. If you feel like maybe your Google skills aren't the best, you can watch Synthesis workshop, Teach Me How to Google, which gives you a lot of excellent tips on how to do that. One of the most important things to do when you're debugging is to turn R off and on again. And when I get started working with new people in R, they don't realize how important this is. But you do want to restart R frequently, especially when things get weird. And there's a very specific way in which you want to restart R. So it also kind of depends on how you have your global options set up in your workspace. Because when you do restart R, you want to restart R with a blank slate. You want nothing there in your environment. You want to kind of recreate the problem from scratch. So what you want to do is you want to set these options in your global options in your workspace. So you want to uncheck restore R data into workspace at startup and save workspace to R data on exit never. So this is like a lifestyle change. That means when you restart R, you're going to have a fresh environment and nothing will be up in your environment, but firmly believe it is the only way to code in R. And then when you actually want to restart R, the way you're going to do that is there's a menu at the top of your RStudio session, and you can say session restart R, or you can do Control-Shift F10 for Windows, or Command-Shift-0, or Command-Shift-F10 for Mac. So our first exercise in Posit Cloud is to actually set these workspace options. So don't open this NHSR link, like that live link, don't use that, use the one in the chat. I can drop it back in the chat. So everyone, I want you to go ahead and go into your Posit Cloud account, and I'll do it at the same time. I'm gonna drop those links again. So we're gonna go into our Posit Cloud account. I believe you should still be seeing my screen. And I'm going to open up the link. All right. I am going to go into my project. That's called WTF Debugging. And we're going to demonstrate those options you want to do. So you want to go to Tools. Hold on. There we go. All right. Tools, Global Options. And you want to, right here, uncheck Restore R data into Workspace at startup, and save Workspace to R data on exit to never. And if you're working in Posit Cloud, then this is only changing, what's happening in Posit Cloud. And I would recommend that you try these options for your local setup as well. So I'm going to apply and click OK. So what that's going to do is if you create an object in your environment called 1, and now you see X as a value of 1, when I go to session, restart R, that object of X is going to disappear. So every time you restart R, you're going to be starting with a blank slate, nothing left hanging over in your environment. So again, I'll show you that again. We're going to go to Tools, Global Options, and then we're going to go to Workspace. This is going to be a default check, so you're going to uncheck it. And this was probably an always before, and you're going to make it a never. Then you have to scroll down and hit apply. Okay. And you have your options for a fresh workspace now. Can I see it in the chat, a thumbs up if this is looking good for you? Yeah, good point, John. There are some options. Use blank slate is another way to execute this, so you don't have to remember where these point and click options are. I think it'll achieve the exact same thing. I'm not sure if it achieves a little bit more or different than that. Thank you for that reminder. All right. I have a lot of thumbs up in the crowd. Wonderful. Oh, perfect timing, down to 8 seconds. Okay. Thanks, John. All right, John says use blank slate is exactly these options. So you have your compute, you Googled your error message, you've restarted R. The next troubleshooting tip that I have for you is to create a reprex. A reprex is a minimum reproducible example. It is a great way of carving down a problem from like a big problem to a much smaller problem. So you can really isolate what the source of the error is. And the reason why you would do that is because a big problem can have a lot of different things kind of hidden and going on behind it that complicate the matter, that make you think you're doing one thing, but what you're actually doing something else. And also a reprex, if you really take the time to isolate that problem, actually most of the time it's going to help you solve your own problem to the point where like you don't need help from anyone else. So that would be my next tip on troubleshooting. And I think I have a link here. Yeah, so make sure you pay attention to this link in the footnote. Make a Reprex Please by Charlotte Gelfand in 2021 was one of the best talks on Reprexes I've seen. It's about a 35-minute talk about the value and how-to for Reprexes. It's really great. Another source of these slides is the Jenny Bryan 2020 keynote, Object of Tight Closure is Not Subsettable, which also talks about debugging tips. And I would highly recommend watching that keynote as well. All right, so we've searched for our problem. We've reset and restarted and we've created a Reprex, and we are still stuck and have no idea how to proceed. These bugs are still coming back at you. Maybe a function is not executing correctly, or you're getting some obscure, weird error message that you're not really sure where it's coming from. And that's when we're going to enter formal debugging tools. So the concepts that we are going to be talking about today are the traceback, which is given a symbol of the road, and that's the location of where the error occurred. We are going to be using something called the interactive debugger, which is given the symbol of the bug, the ladybug thing. And it gives you the context of why the error occurred. And then we're also going to be differentiating between tools and techniques you can use for your own code with a magnifying glass, and tools and techniques that can also beyond help you break into someone else's code, which is the wizard hat. So imagine code that lives in a crayon package that you don't necessarily own the source code for. You can still break into it. So we're going to be talking about the traceback. Where did the error occur? The context of why the error occurred via the interactive debugger, how to use these things to apply to your own code for which you own the source code for your functions, and how to use these things to apply to other people's code, the wizard hat. And this is the full scope of things that we are going to be talking about. So we are going to be talking about functions you can use, like traceback, browser, debug, trace. We're going to be talking about options you can set in RStudio. And we're also going to be talking about things you can do in your RStudio IDE. And as you can see, they all have different icons, right? So some of them are good. Some functions are good for the traceback. Some options are good for the traceback. And some things in the IDE are good for the traceback. We also have things that trigger the interactive debugger. All of these things have a magnifying glass, so you can see, which means that they are all good for your own code. But only some of these things have a wizard hat. So some of these things can help you break into someone else's code or help diagnose someone else's code. It's a lot. It's like really a lot. And all of these tools achieve similar objectives in slightly different manners. And people do not use all of these tools at once. They like pick and choose the ones they like. So my hope for today is to give you an overview of these tools so that you yourself can find the one that you like that works for you. I certainly have one that works for me that we should be able to get to the conclusion of the workshop. Just kind of before we get into the code, what we are going to be doing is kind of to illustrate working with our own code. We're going to have a script in R called my functions. It's only going to contain the body of my functions. This is where I'm going to be demonstrating things in R for you. And then of course you will have the turn to demonstrate your own turn to demonstrate our work in Posit Cloud. But what you're going to be seeing me doing is I'm going to have a script that's named with my functions. And it's really important that I source that script in with functions for the best debugging experience. So that means I am not just copying and pasting the code and submitting it to the console, but I'm actually clicking that source button that gives us some extra context about our code that you would not have if you just copied and pasted it into the console. All right, so here is our setup for our first exercise. And now I'm going to move over to an instance of R. You don't have this setup in Posit Cloud. Posit Cloud is solely for your exercises, and we are going to break for exercises at designated breakpoints. So you can just watch as I go through these. I'm going to get my R instance up over here. And I am going to kind of come over here to my functions. I'm going to clear my screen and I'm going to reset R. All right. So I restarted R. Nothing is up in my global environment. And I'm going to, and you are still seeing my Posit Cloud screen, right? Or sorry, not my Posit Cloud, my, oh gosh, my RStudio screen. I don't want to be in Posit Cloud yet. Okay, all right. So here's my RStudio screen. Thanks for the thumbs up, Mo. All right, so here we have my functions, and what I'm going to do for you, or for myself, is I'm going to source this script in. So again, we said we don't want to just copy and paste it. We want to source it in. So we've sourced it in. Now I have these functions f and g. So all f is doing, g is a function of x, and all we are doing here is adding 1 to an object. So 1 plus 1 is 2, and that works. But on the other hand, if I call g of a as a's character, you are going to get an error. So our objective here is kind of trigger errors and trigger them many times and show you how you can work through those errors. Also just kind of rearranging my screens so I can see everything that I want to do at once. So bear with me. Okay, so we have triggered our error, and say this error is just mind-boggling to us. How are we going to go about diagnosing this error? I'm just going to jump back over to my slides real quick. So now we're going to debug our own code, because these are our own functions that we have written and we need to debug it. So there's our error. I'm not going to show you this, but some ways that people approach debugging is via print methods. So you can insert print statements into your functions to print out values of objects at different points in your function. A similar way you can do that is with the cat function as well, maybe to perhaps supply a little bit more context. And these print debugging methods are like time tested. It's definitely a way that people work and operate, but it's not the focus of our discussion today. So I want to focus on proper debugging tools. So the first thing that we are going to look at is the traceback. And the traceback shows the sequence of calls that led to the error. So if we source my functions, then trigger the error at g of a, then we're going to call the traceback to it. So I'll just restart R just so you can see that sequence of events again. All right, so I'm going to source my functions. I'm going to trigger an error. And now all I need to do is call the traceback function with an open close parentheses. And it's just going to show me the sequence of events that led up into the error. So we can see the first sequence is that G was called with an argument of A. And then it tried to execute step 2, which was f of x, and f of x is where the error actually occurred. So traceback is showing you the sequence of events that led up to the error. There is a way you can trigger kind of a more informative traceback. So I'm going to go ahead and restart R. Actually, I'll just show you the slides real quick. So what we're going to be talking about now is an option that you can set in RStudio via the rlang package. So if you use the options error equals rlang and trace, that will give you a more informative traceback beyond the base R traceback method. So I'm just going to restart R again for good measure. I'm going to go over to R recover. So I'm going to source in my function. You can do that using the source command, or again, I also did that before by using the source button here. I'm going to set my options to R error equals rlang and trace. So that's an error option that I am setting. I'm going to trigger an error by calling G of A, which we know is not going to work. And then instead of calling traceback, I'm going to call rlang last error. You can also call rlang last trace, depending on the complexity of your error. You may or may not see different things. And you're going to see just a slightly different printout than what we saw before. So you can see how functions are nested or called from each other instead of just in the traceback. I think I cleared it. And the traceback, it was just kind of sequential, but it doesn't show you the nesting. And then it also kind of shows you the row and column number where that error was actually triggered. So it's row 5, column 5. If we go back over to my functions script, that's like row 5, column 5. I don't know about the column thing here, but basically it's saying it was triggered on row 5 here. So that's kind of what some of the additional context that the sourcing can provide to you is kind of these row and column positioning as well. Now, since I created these slides, the behavior of last error and last trace kind of have migrated to be a little bit more similar. So depending on the complexity of your error, you may or may not find last error or last trace more informative. And another thing that you could do is instead of setting options interactively in your R session, you could also set that in your R profile to kind of always have it as the default way to look at errors. So that's a traceback, which is showing you the location of your errors. And if you're using different functions to examine the traceback, and there's like a lot of ways it's also been called, like the back trace, the trace back, there's other things. Just want to point out that the ordering and numbering of the base R traceback function is a little bit different than the rlang functions. So this is from the advanced R book. So you're going to see like different sequencing. So traceback is going to show you the most recent call at the top. The last call at the top versus rlang is going to show it to you in the opposite direction. So if you're experimenting with those functions, I just wanted to let you know that those ordering is presented differently. All right. Now we're going to show how you launch the interactive debugger. And before we get into that, I just want to pause and see if there's any questions in the chat I can address. I can find my chat. I don't think there's any questions in the chat. Okay, I'm good because I love the interactive debugger. So let's get into the interactive debugger for the first time. There are many ways you can launch the interactive debugger, and here's just the first way I'm going to show you. So the first way you can show you is with the function browser. Yeah, it's okay that your repository doesn't have the demo directory. I was thinking as I got started this morning that maybe I should throw the demo directory into the exercises so you can more easily follow along. I'll do that in the next iteration. The demo directory was created elsewhere, but yes, sorry about that, Erin. All right. Well, Mo says browser is her staple. Let's see if I can get her to start using some other things throughout this. People might be browser diehards. That's fine. And like I said, there's a million ways, not a million, but there's a handful of ways you can do this. And it's up to you what works for you. So browser is a way to open your interactive debugger. I think you're not on mute, Mo. Mo, can you mute? Or someone maybe.
It's not me.
Okay. All right, I think I found the person. Okay. And you do this by actually putting the browser statement and the body of the function. Then you're going to source the function, and execute the function. So I'm going to go back to my R instance. I am going to restart R. I'm in my functions, and I'm literally going to change the body of my function with a browser statement. So again, I'm going to source that function to get that function in my global environment. And now I am going to execute the function. Now the browser function is going to work equivalently, whether or not you trigger an error or you actually would have a correct execution. It is literally going to stop the execution of your function, and it is going to open something we call the interactive debugger. So I'm actually not even going to trigger an error. Like, we know G of 1 should work because it's just 1 + 1 is 2. So it's not going to trigger an error, but it is going to open the interactive debugger. How I know that my interactive debugger has been opened is through a few ways. So you can see now that there's a highlight on line 2 that's showing that's the active line that we're working on. You can see over here in your environment that there are different values in your environment. We are working in the environment for the function, not in our global environment. It did pop up a trace back for me. It may or may not do that for you, depending on kind of what's been executed. And then we also have some toolbars over here, which I will go over shortly. Another cue that we are in our interactive debugger is our prompt has changed. So instead of just showing the caret, we have a browse 1 and then a caret to say it's ready to receive a new command. Now, what we're doing right now is we're living in the environment of our function. So our function took an object called X. I can see what the value of that object called X is by submitting X in my browser or in my console. So your console continues to function as a regular R console. You can execute anything you want in your console. Like, if I just want to know if X + 1 will work, I can write X + 1 there. It is still a regular console where you can play with code and execute things as needed. So one helpful command might be here in your interactive browser or in your interactive debugger is ls.stir, which will kind of tell you all of the objects in your environment and their type or class. Let's see here. What are the other things I wanted to? I'm going to pop over to my slide real quick, and then we'll go back to our debugger. So ls.stir, stir, print, these are all kind of helpful objects here. So ls tells you all of the objects in your environment. It's just X. We can look at the structure of X as numeric 1. What else? And then we have different keyboard commands. So in means go on to the next statement. C means continue. S means step into a function call. F is finish the loop. And I think down here where you cannot see, is there a capital, a Q, a lowercase q, a capital Q, which tells you to quit the debugger. So I'm going to hit in, which is going to move my highlighted line here down to line 3. So it's going to execute the next line of code by hitting next, or it's going to make the next line of code active, I guess, not yet executed. So we have moved down to the next line of code. If I hit in again, and now it's going to execute that highlighted line of code. And it's also exiting the debugger. Because that was the end of the function. There was no error. It returned the result of 2. And so now the debugger has been exited because you no longer see this like browse prompt in your console. You no longer see this different function environment. You no longer see that navigation pane that was around before. I'm going to do the same thing, but I'm going to do it on an error. So this should trigger an error. Again, we are on our browser. We can hit in to execute the next line, in again to execute the next line, and it does exit when we hit the error. So either way, you're going to be exiting out of your interactive debugger anytime you successfully complete execution of the function or you hit your error, the debugger will exit. Another thing to know is that your browser doesn't have to open on line 1. Your browser could open on line 2. So there's a question in the chat. Why does it say browse 1 or browse 2? What did the numbers indicate? Let's see if it does anything else when I open it on 2. I think it's kind of the number. I don't know. Let's see what happens and see if anything does different. Okay, so I'm going to restart R. Yeah, I think, Martine, it is kind of like the number of, let's see what happens when I move the browser statement before I say anything. Okay. All right, so I restarted R. I'm going to source in my file, and my source button is a little hidden there. So I've sourced in my file. I've moved the browser statement down 1. So that browser statement can be located anywhere you want in the body of your function. It just kind of depends on what executes in advance of opening that interactive debugger. So now I'm going to execute my function on an error. Let's do not an error first and see what happens. So I'm executing my function, and this might be a weird example. So it still calls on browse 1. So it is kind of the first line I'm executing once that interactive debugger has been triggered. So I guess the 1 and the 2 indicates like number of items. So, oh, I bet it corresponds to like the line number after your browser, the 1 and the 2. So like ls.stir isn't going to like change the browse number because we haven't executed a line in our function. But if we hit next, it probably will. And I think next is going to be kind of a weird example here because we're already in the browser. So it's just going to exit. And then if I do the same thing with an error, because the browser was called after the error was already triggered, it just triggered the error, and the interactive debugger like never actually opened. All right. So can anyone in the chat kind of think of possibly like a drawback to the browser approach? Yeah. So John says you have noise to clean up in your code, right? That's right, Lee. So you have to type in browser and then clean up after, right? So like, let's say you've like gone through your interactive debugger steps and you're like, that's great, I am done. Now you are like, uh-oh, I have to actually remember to remove browser from the body of my function in order to get it back to its like working state. So it's just something to remember to do after to remove that browser statement. And again, this is a function. Browser is a function you would use if you own the source code for, or if you have the source code in front of you. The reason why you're likely to find a commented out browser in my package. Okay. So I believe it's your turn now for your first exercise. So what we have done so far is we have hopefully, are you hearing the dog in my background? Apologies. We have covered the yellow highlighted bits in debugging your own code. So we've kind of briefly mentioned print and cat, which we're not going to go into detail. We've talked about traceback, which is where you're going to locate your error, browser to open an interactive debugger in a specific location. And we've also talked about an option you can use for error, rlang and trace. So it is your turn. In the interest of time, I'm going to kind of walk you through what you see in Posit Cloud so that we can kind of get some things rolling here. What I'm going to do is I am going to show you what happens when no error is triggered. And then I'm going to let you see what happens on your own when an error is triggered. So I'm just going to start the timer, and hopefully this will be enough time for us to be going. So I'm going to go over to Posit Cloud. My project went to sleep, so I am going to resume it, wake it back up. I'm laughing because in the chat, someone has said they had triggered a browser within a browser and it was not the best experience I can imagine. All right. So if you look at the README here, we're going to be working on exercise 1, which is practicing debugging your own code. And in each exercise, there are 3 different scripts. If you feel like pretty comfortable with your debugging techniques, you might want to go with Spartan or Comfy. So Spartan has directions to explore without suggested code. Comfy has directions to explore with suggested code. And the debugging solution is actually what I'm going to open. It's directions to explore with code solutions. It's not going to like tell you how to solve the problem. It's just going to kind of walk you through what you're going to do. So I'm going to open up 01 debugging solution. And I'm going to show you this setup, and I'm going to show you kind of what happens when there is no error triggered. So the example that we're looking at here is actually from Jenny Bryan's RStudioConf keynote. Object of type closure is not setable. So if you've seen that talk, this will possibly look familiar. So I'm just going to open up the source.me file. I just hit Control Enter on file.edit. It opened up the source.me file. So what the source.me file has is it's got a data frame of fruit and a function that computes a fruit average. So I'm going to source that file in via the source command. And again, like I just said, we have a data frame called fruit. I wonder, is the font big enough? Do I need to make it bigger? Are we good? I'm good. Okay. All right. All right. So we can look at our fruit data frame that we have input in. So it's not a tidy data frame, but it is a data frame. So we have a column for blackberry, blueberry, peach, and plum. Over here in Pennsylvania, I just did blackberry and blueberry picking last weekend with my kids. They were very delicious. We also have calories for those fruits, the weight, and a yumminess factor for the fruits as well. We do have a fruit average function as well. So we have viewed the fruit data, check, and we are going to execute the fruit average function. It's going to be a successful execution. So fruit average berry. What it's going to be doing is it's going to be looking for the 2 columns that say berries and calculate average calories, weight, and yumminess for those berry fruits. So it's looking for anything that says berry. Now, on the other hand, when we calculate it for peach, you know, peach is a little bit different. There's only 1 peach, not like unlike the 2 berries. And we're going to observe an error for our peaches. And so the error kind of goes back to some row means that we are going to kind of try to get to the bottom of. So I'm going to find the location of the error via traceback. It's going to tell you the steps that executed to get back to that error. We are going to modify our options to use rlang and trace. And you are going to see, I think I might have hit it too fast. A different kind of trace back for the steps that it took. So it says our global function fruit average entered the base row means function, and that's kind of where the error was executed. So we're going to get into interactive debugging. So I'm going to go over to my source.me script, and in the body of my function, I am going to put a browser statement at the top. You can put it wherever you want to put it if you think, depending on where you think that error is getting triggered, it might be advantageous to put it in a different position. I'm going to save the source.me script. I'm going to restart R. I am going to source the source.me script. And instead of triggering the error this time, I'm going to walk through it by triggering not an error. So I'm going to walk through it for berry and show you what it looks like when there is no error triggered. And then I'll give you time to work on your own for when an error is triggered. All right. So there's no error triggered for berry. We already know that. And we have opened up our interactive debugger. We can see what's in our environment. So our fruit average is a function of some data and some pattern that we are looking for. So data or dat and pattern are in our environment. We can take a look at that with ls.stir, and it's going to kind of tell us the objects in our environment. So dat is a data frame of 3 observations and 4 variables. The pattern that we are looking for is a character string called berry. And then if we hit next, we're going to see that it finds we're on the row calls. So it's not yet in our environment. Calls hasn't actually been triggered yet. So this highlighted line is waiting to be triggered. So I'm going to hit next. And so now we have triggered calls. So we can take a look and see what calls is. And so it's calling in columns 1 and 2 correspond to the pattern of berry. I'm going to hit in again to execute the next line where we're computing a mini dat. And a mini dat is just going to be a data frame that's reduced for only the columns of interest. Then we're going to execute a message. We found 2 fruits that correspond to berry. And then the last thing that we do is we compute those row means of those 2 fruits in Minidat. So we're going to do next to execute those row means. And now we have successfully executed the function. What I would like for you to do is I would like for you to do the same exercise, but only using trigger and error on Peach, and see if you can get to the bottom of why Peach triggers an error, but row means does not. So I am going to, let's see what time. There's 7 minutes left on the timer. So I think that's a good amount of time for you all to work. So I'm going to leave the timer up and I'm going to go on mute. You're welcome to put things in the chat, and I'm going to give you time to work on that Peach execution error. So if you think you found the essence of the problem, certainly drop in the chat. If you have any questions at all, certainly drop it in the chat. Yeah, so at this point in this workshop, I tend to see a lot of enthusiastic art programmers very curious about what the actual problem is and how to solve it. And I guess, you know, there's one level of how to solve it for Peach and another level of how to solve it for any arbitrary pattern that may be submitted and not return a result. But we have come to the conclusion of our time. I think it is important. Whoa. Did everyone hear that noise? Is it just me? I got like a Mario noise there when the timer was up. Okay. I think it is important to articulate actually what the error is, not just the solution. So let's trigger the debugger again, but with an error instead of a solution, and maybe we can slowly together understand why there's that source of the error. So we're going to go to Peach, which we know there's only one column of fruit corresponding to Peach. We're going to open up our debugger. We can kind of take a look at the objects in our environment. So we have the pattern that we're looking for is a peach. Now, previously, when we called berry, we found two columns that corresponded. And now when we call berry again, we should only have a single column that corresponds to, sorry, when we call peach, we only have a single column that corresponds to peach. It's column 3. So we're kind of trying to extract column 3 and create a data frame from column 3 only. So we're going to our mini-dat, and we're going to create our mini-dat. And when we have our mini-dat, does anyone know what type of object mini-dat is now? Where as a differentiation to what it was before. I see a string. That's kind of close. Yeah, it's a vector, right? So this is a vector now, when before mini-dat was a data frame. So mini-dat is a vector of integers, which is different than before when we called berry. It retained that data frame structure. So the structure of mini-dat actually did change when we only found a single column versus 2 columns. And then that data structure change is what's triggering this error. So now when I call a message, the message looks a little wonky, found like, I don't know how many fruits, because like if I try to execute in call of Minidat in my console, like there's no columns in Minidat, it's just a vector. And remember, your interactive debugger is just, you can submit whatever code you want to in your interactive debugger. It is just a console. It is just a place where you can submit any code you want to kind of figure out the bottom of it. So there is no columns in a Minidat because it's a vector. And then when I try to take the row means of a vector, that's when we're also going to have a problem. Now I could hit next and in for next, and that would trigger your error and it would close the browser. Another option that you have here instead of in for next is you can actually hit S for step into. So that means like I know where row means is going to trigger that error, and I actually want to step into the body of that function and execute that function line by line. So let's see what happens here. Whoops, I would think I was in my source script instead of my browser window. All right, so now that I'm on my browser window, I'm going to hit S for, oh, I think I lost it. I don't know. Let's see here. Okay, yes, I did step into row means. So now I'm actually in the body of the row means function, and I now can use my browser or my debugger to kind of go through the row means function. It is a little wonky with regards to like what lines are highlighted and all that, because we don't have the, like, this isn't our source code, it's from base R. So it says like the debug location is approximate because the source is not available. So it takes a little bit more getting used to, but so basically we are on this line here, if stop array must be at least 2 dimensions. So we're kind of checking that dimensionality here. I'm going to hit in for the next one, and another in to kind of keep going through. And that's kind of where our row means error got triggered. Like we're looking for dimensionality to our data frame that we don't have, because when we called for Peaches, we only had a vector instead of a data frame. Come back in Minidat. That browser statement got kind of jumbled in my source code. I'm gonna save it without the browser statement. And then I did see a lot of chatter in the chat about the solutions to the problem. And so there are certainly different ways you can go about approaching it. And just in the interest of you all focusing on debugging techniques and not getting to the bottom of this, let's go ahead and look at the secret fixed fruit average function. So again, the heart of it is coming with that Minidat. And one thing that you can do on Minidat to correct it is in your brackets that do the subsetting, you can actually use a comma drop equals false option. And that will actually do the correction here. So that is that's a suggested correction, and then that will make sure you return a data frame instead of a vector, even when you only find one column. But we're going to keep the well, I know, right? God, what is this magic? Yes. We're going to keep the buggy fruit average function as it is buggy, so we can continue on with our illustration of debugging. I think if you didn't see it earlier in the chat, there was a suggestion from John to check out the help file. So you're going to do a question mark, backtick, bracket, backtick, which will pull up the help file. And then you can see different options that come with brackets as well. So there is our drop option. Okay, I'm gonna go back to our slides now. Okay, now we're going to talk about some things that you can do. How did I find this? I watched Jenny Bryan's keynote many times. in RStudio. So these are RStudio specific options, as opposed to like a browser function you can use in an R console, like in whatever code development environment you want to use it. It's a function, like it's independent of what you're doing in RStudio. RStudio does have some specific options as well. So one thing that works equivalently to the browser function is something called an editor breakpoint. The editor breakpoint is a red circle that goes to the left of your row line numbering in your source code. And so when you see that red circle there, it's called an editor breakpoint, and it actually functions equivalently to a browser statement, but you actually don't have to change your code. So when the red circle is there, it's like equivalent to saying, put a browser statement here. To set or reset an editor breakpoint, you're just going to click to the left of that line number in your source file. And to activate it, again, you want to click that source button, or in this case, instead of using the source function, if that's what you're using to activate your function, you would use debug source instead. All right, so I'm just going to show you not in Posit Cloud, but over here in my regular local R instance. I'm going to restart R. I'm going to set, I am going to click on to the left of that line number. It's an open red circle. It says breakpoint will be activated when this file is sourced. So I'm going to source this file now. Now this function has a breakpoint on it. You can also see that over here in my global environment, there's a red dot next to F. And now, regardless of whether or not I trigger an error, like so one is not going to trigger an error, it's going to execute correctly, but it's still going to function as a browser statement. So now I have opened my interactive debugger, and I can proceed as usual, like trying to figure out what's in my function environment, click the next button, and it'll kind of exit because there's no more to go through. I can also do the same thing when I'm going to trigger an error. I can figure out what's in my environment, and I can hit next, and then that's when my error is going to be triggered. So that breakpoint does function equivalently to the browser statement. And again, just like you can insert that browser statement anywhere in the body of your function, you can also put that editor breakpoint anywhere in your R script as well. And yes, before I got used to debugging techniques, I had put that red circle there myself and like accidentally clicked and had no idea what it was doing or why it was there, right? So if you've ever accidentally clicked and seen it, that's what it's doing. It's equivalent to the browser statement. Now, some other things that you'll notice in the RStudio IDE that like I didn't kind of talk over before because I was trying to do like things that you could do regardless of the IDE, like we did N for next and S for step into, Q for quit. Your debugging console does have these handy buttons that you can click on instead of remembering the N, the S, the Q, and all that. So you can click on these buttons to step through your code, to step into and out of functions, and to quit your debugger. So just to kind of show you what that looks like again, I'm going to trigger my interactive debugger. And instead of hitting N for next, I can just click this button and then it'll execute the next line and trigger my interactive debugger again. I could, like I did the step into last time. I don't even know what this is going to do if I step into this. Yeah, there's nothing to step into. But it is kind of putting that execution command on your browse statement for you as well, the N and the S, so you can see what you're actually triggering. So that's handy. So you can just click those buttons to click through, which is what I normally do instead of using N and S and Q and all of that. There are also IDE options, and to be honest, I don't use these IDE options, but I think because like when you do see them, they can be confusing. I'll show you what they do. So if you are in RStudio and you go to the debug menu and you go down to where it says on error, there are 3 different options there for you. So there's a message only option, an error inspector option, and a break-in code option. I think the default for most people is the second one, the error inspector. I think it's the default that you see in Posit Cloud as well. And I'm going to give you a new setup for demonstration just because these are a little bit require just a little bit more setup to trigger. So here is our new setup for demonstration, and I'm just going to go back over to RStudio to show you. So I'm going to take that one off. I'm going to restart R. I am going to go actually over to this untitled script, which has my setup. So I'm going to go F is a function that splits a character string. G is a function of X. So when I call G of the character string A comma B, it's going to split it down here. So it splits it into I guess a list where 2 elements, A and B, but if we call it on a factor, string split actually only takes a character argument. It won't take a factor argument. So that's when you trigger the error. Now, if we go back to debug on error, so mine was set on message only, and that's why you saw the message regarding the error. If I move it down to error inspector, and then I'm going to re-trigger the error again, you're going to see a different printout that didn't show up before. So message only shows you the red message. Error inspector, I believe is what we had open. So error inspector gives you 2 options now. Error inspector says you can either show the traceback or you can rerun with debug. So show traceback is just like running the traceback command that we talked about, or like, I think, yeah, it's just the base R traceback command showing you the sequence of events that led up to your error. It's not the rlang ntrace option. And then the other option that we have here is to rerun with debug. And rerun with debug is actually what is going to open up that interactive debugger for you. So now if we click on rerun with debug, here we go. Now we are in our interactive debugger. Sometimes for me, it pops you into a place that you're like, I don't know where I am and I don't know how I got here. And for that reason, I tend to not use this option. So it is opening a function, the string split function. And I'm, to be honest, I have no idea what's going on here, but it opened it up for you. And you could click in and like go through the steps. And I think it already errored out for me. The last option you have on your debug window is on error break-in code. And on error break-in code will actually just automatically open up that interactive debugger for you. And it doesn't even matter. No, you do have to be on an error. So here we're triggering an error with calling a factor, and it's just boom, straight into the interactive debugger anytime you have an error. But also kind of dropping you into this place where you like might not have any context as to like how you got to this place and from where. So that's another kind of thing that's kind of nice to know about. Just like if you accidentally clicked a red circle, you might accidentally have some different settings on here on your error. I tend to leave mine on message only and get into tracebacks and debuggers via other means. I will pause for questions. The error inspector, it's like only invoked if your code is involved. So it kind of took me a few iterations to kind of figure out when the error inspector would trigger, but it's like nuances beyond this class, so don't worry about it too much. So in this section, we talked through debugging options that are exclusively used in RStudio. So if you're using other editors or whatever, you're not going to be possibly not going to be able to use these debugging options. So you can use a breakpoint, which opens your interactive debugger, and it's equivalent to a browser function statement. And then you can do debug on error or debug on error break into code. So exercise 2 is to practice debugging a slightly different version of your own code using features from the RStudio IDE. How about I pause here? I'm going to let you play around in Posit Cloud if you want to, or take a 5-minute break because we kind of already done this. But if you want to use your browser statement or practice with the different IDE options, that's fine. But let's just take a 5-minute stretch break or an exercise break, and we'll come back in a few. All right, so I will just demonstrate really quickly. I could find my Posit Cloud instance. Here we go. How to get back, use some of the IDE options. So I'm going to close my session 1 scripts. I'm going to open up exercise 2, open the solutions again to get started quickly. I'm going to restart R. I'm going to open up the source me file and, oh, I forgot to tell you, sorry. Exercise 2 has a slightly different setup that I should have told you. So before exercise 1 kind of had a single function that we, to do all of this, exercise 2 was broken up into a series of mini functions. So find columns, reduce data, create the message for the fruit, and they compute the average. I'm sorry, should have told you. And then the point of it was to kind of experiment a little bit more with this S step into function, so you can see what happens when you step into it. So in terms of what we can do, we could actually just put our breakpoint anywhere we want in the function. So instead of doing it on column 27 or line 27, I'm going to do it on line 28. It's going to kind of execute the commands prior to that so that you can kind of open it and dive right into where you think that error might be. So we've already sourced it in. We can verify that it works great for berry. I'm going to go ahead and execute it for peach. So now that we have opened the interactive debugger on peach, you can see what's in your environment. And you can see that the pattern we're looking for and the calls we're returning, we're just returning the 3rd column. And now I can try stepping into reduce stat and see what happens instead of hitting next. So I'm going to use this step into function. And then you can see it actually takes me to the body of that function for reduce stat. And I can kind of execute the lines that are going through in reduce stat. So I'm going to execute, and it's going to finish execution of reduce stat, and then return me back to my fruit average function, where now I can see what is in my mini-dat if I wanted to, and it's just that vector. I could step into message fruit, or I could just execute it. When I compute average, I could try to step into it and see what happens. And that's when it's going to say, okay, well, compute average is a function of row means. And now I can step into row means, and it's going to bring me back to where I was, where it's trying to check the dimensionality of your input in order to compute the row means. I'm going to go ahead and just click this red square to stop the execution. So we did opened the interactive debugger via the breakpoint. We can also do so in your debug options on error. It's got me this error inspector here. So I'm going to trigger an error again via trying to call peach. And I was expecting not to see a message. I was expecting to see something else. Debug on error message only. Let's see here. I think I restarted R, so I'm going to source things in. I'm going to see a message with an error now. I'm going to go back to on error to error inspector and see what happens. And I got the same result. I was expecting to see the options with the traceback and the break into code. Let's go into the break into code option. And so the break into code option is the one where it just kind of plops you into exactly where the error is happening. And if we hadn't stepped through this fruit average function so many times, it would probably be a little disarming to drop you straight into row means and be like, whoa, where am I and how did I get here? So that's one reason why it's not my favorite option to use. All right. So that is what you can do in the IDE. And so far, we've been really focusing on if you own the code, right? So we had the source code for these functions, but there are instances where you might want to debug where you actually do not own the code. So you want to debug someone else's code. So now we're going to put on our little wizard hat to figure out how we can do this. So the browser function and the breakpoint red circle, they work because like you can access the source script and you can modify the body of the function to put a browser statement in, or you can left click to the line to put a breakpoint in. But if you don't have the source code, then you cannot modify the body of the function. So an alternative to use here is the debug function. So the debug function is equivalent to a browser or a breakpoint in the first line of your function. So I'm just going to demonstrate this by going back over to my local R instance. So let's do this. I'm going to go back over to this function. I'm going to restart R. I am going to source in these functions. Then I'm going to say, I want to debug the function G. I'm going to call the function name in quotes, and nothing is happening at all. In order to trigger the interactive debugger, now I actually have to execute the function, either on an error or not an error, it doesn't matter. So I expect my interactive debugger to open. And now it's behaving slightly differently, right? Like it's not jumping to that my function script. It's saying it doesn't really know where the source code is. And now we know that we're trying to execute f of x, and we click next, and it kind of bumped you down because it actually worked. It's a little bit kind of easier to see the steps when it's like a little bit more of a robust function with more steps. But basically, if we try to execute the function again, it's going to open up my interactive debugger again. And if I try to execute the function again, it's going to open up my interactive debugger again. If I try to execute the function again, it will open up my interactive debugger again. So once you have opened debug, you actually have to tell R to stop debugging that function. And the way you would do that is by submitting undebug. So I'm going to undebug G. Now, when I execute my function, it will actually not open the interactive debugger and return a result. So it is a way you can break into code that you do not own, or code equivalently that you do own, but you have to remember to hit undebug on it. And like it hasn't happened to me because I don't use a debug that much, because I get a little nervous because I've heard that depending on what you're doing, you can get trapped in the debugger if you're using the debug function. So I tend to stay away from it, so I don't have to remember to do undebug, or so that I don't get trapped. I don't know what that means, but you can get trapped in the debugger. So, but it is an option. Especially if you don't own the source code. An alternative option that is my most frequently used option, it doesn't have to be yours, but it's just my most frequently one, is I love debug once. So debug once, it's still the equivalent of debug in that it inserts that browser or breakpoint in the first line of your function, but it does it one time only. So you actually do not have to remember to undebug. Like you do have to remember to trigger it every time you want to get back into that undebugger, but you never have to remember to untrigger it. So if I go back over to my local R instance, I am going to debug once G. I'm going to trigger the debugger by calling either an error or not an error. I'm in my debugger window. I can hit in for next. I've exited my debugger. Now, when I trigger G again, it just executes because I've only debugged it one time. Now, I do have to remember to keep triggering the debugger if I haven't gotten to the bottom of my issue. So I'm going to debug once. I'm going to trigger my error. I'm going to try to figure out what's going on. I'm going to hit in for next. I'm going to see my error. And then I'm going to trigger it again. And then I just see my error again. It's not opening the debugger again because I've only debugged it one time. So So that trade-off between, do you want to have to tell it R to keep opening the debugger, or do you want to have to tell R to close the debugger? It is whatever works for you. And again, you can use this if the source code isn't yours. Another option you can use for your errors, like we've already discussed, error equals rlang and trace. You can try the option error equals recover, which is an interesting error option that it lets you look at single frames of your function, and you kind of get stuck in like a single frame, which is hard to describe, but I will come over here and try to show you. So let's see here, error recover. I'm going to do restart R. I am going to source in my function. I'm going to set the option to error equals recover. And now we're just kind of gonna jump into my G function, but it's going to ask like, where do I want to jump into it? So do I want to jump into it when I call G of A, or do I actually want to jump into it when I call f of X? And so you can kind of just tell R what frame you actually want to jump into, and then you'll get stuck in that frame until you get out of it. So I'm going to hit N for next. And then it's like, do you want to go back into that frame, or do you want to choose a different frame? Well, maybe I'll choose a different frame to go into. And I'm trying to execute this. I think this is going to trigger an end because I'm going to hit, oh no, it never triggers an end. So it basically only lets you like stay in a frame at a time, and you never really get out. But if you kind of really want to isolate a specific place in your function that you need to work and like really figure out what's going on, then that error recover might be a good option for you. And you can reset your options with error equals null. We're not going to really have time to go over this in depth because I do kind of want to give you a little bit more time to practice debugging someone else's code in exercise 3. But I do want you to know about trace function. So you can use a trace function to debug something, which is equivalent to inserting. If you specify tracer as browser, it's equivalent to inserting a browser in the first line of your function, which you can also use to like insert at any line in your function. So you can specify you want to insert it at a second step in your function with an @ equals argument. And again, you might want to do this if you don't have access to the source code, but you want to break into someone else's function at a specific step. And in the interest of like letting you practice with debug and debug once on someone else's function, I'm going to kind of skip over to exercise 3. Maybe let's call this, we'll work on it for 7 minutes, and then we'll pop out and kind of have a wrap up. I'm going to open Posit Cloud to kind of orient you to exercise 3. So exercise 3 is another different take on the fruit average function. So I've restarted R, nothing's in my global environment. I'm going to open up exercise 3 solution, which remember says to restart R. You actually do not have to execute this line, this DevTools install line that has already been done for you in this workspace. You should just be able to execute library WTF debug. And that, when we look at our WTF debug package, it's just going to come with a couple of things in it. So it's going to come with the fruit data that we saw before. It's going to come with that fruit average function that you saw, which is composed of a series of mini functions which were exported in this package. So there's our fruit average function that worked. And now we have our fruit average function that does not work on Peach. And so I want you to kind of go through the same steps of debugging, but with functions that you don't own the source code for. So practice with debug once, the tracebacks. I'm going to give you a few minutes to work it out, and then we will come back. So how about we just do 5 minutes on this exercise? So I'll pause at 5 minutes here. Yes, you do have to call library WTF debug. You just don't need to install it. The package has already been installed. If you're working locally and you cloned the exercises repository, you will need to install the package. Yeah. All right, so we'll go ahead and break here. I'll open up Posit Cloud again. I have called library WTF debug, and there is no source code for me to modify here, right? So this fruit average function now exists in some other package that I cannot insert a browser statement or a breakpoint in, but I still need to figure out what's going on. So I can still, use my traceback option to kind of figure out where that error occurred. So it executed fruit average, then it executed compute average, and then it stopped at row means is where my error occurred. Or I can use my rlang and trace to kind of get that richer traceback view. So I'm going to do last error, and it kind of tells you we're working with the fruit average function and the WTF debug package, and then we called the compute average function in the same package. And then that error actually occurred when we tried to trigger row means from the compute average function. We can use debug once to get into the interactive debugger a single instance or a single time. So now when I execute fruit average, I'm going to launch the interactive debugger. Again, because we don't own the code, it says like debug location is approximate. It's going to do the best that it can, but we can still use our next buttons to kind of walk through our function step by step. And we can use our step into buttons to kind of step into different execution calls of the function, or the smaller functions that compose the bigger function. Again, remember, we can execute any code we want to in our browser console to see what's going on and why we might result in that error. And we know that when we look at our Minidat, it is a vector instead of data frame. So when we execute our messaging function, we have no fruits to create a message about, and we could either execute compute average, which will result in an error, or we could decide to step into it. And so debug once is just going to open that debugger one time, and then we can execute it again, and it's just going to result in that error because we're not in the debugger. So what we have done today is a lot, right? We've talked about different ways you can find tracebacks. So you can use the error inspector, you can use the traceback function, or you can use an option from the rlang package, which provides a little bit more of a more visual traceback. And we talked about a lot of different ways you can launch that interactive debugger. As some of them only work for your code, like the breakpoint or the browser, and then some of them are going to work for either your code or someone else's code. So the debug once options, the trace option where you can insert a browser statement anywhere you want, and then error equals recover option will also open in that interactive debugger. And so if you're interested in that traceback, you only need to use one traceback technique. You don't need to use all of them. And if you're interested in the interactive debugger, you only need to use really one interactive debugging technique. You don't need to use all of them. Like while you're getting familiar with it and getting started with it, you might experiment with the different ones and see which ones feel the most normal and natural to you until you get the hang of it. And then after that, you're probably just going to pick one and stick with it. In the interest of time, I'll just like kind of, because we're at time, right? And I will just say, like, anytime you find a bug, of course, it can be frustrating and troublesome, but you will eventually, of course, always learn something from your bugs that makes you a better programmer in the end. So learn from your bugs. Don't forget your basic troubleshooting techniques before you get into proper debugging tools. And I hope you had a good time on the call this morning and learned something new. And thanks for joining. I'll take any questions. If you want to stay on for a bit, I'm happy to stay on for a few. If you need to leave, that's fine as well. And I guess I'll go ahead and stop the recording as well. Thank you for the help. Ella, Mo, do you know where the stop recording button is? Oh, there we go. Stop recording.